Is this always the same person, and which of the images are generated? Well, you've guessed it. All the images are generated. I've used DreamBooth to fine-tune existing Stable Diffusion models with my own images. If you want to know how this works, this video is for you. Frankly speaking, making this video took much longer than I expected. Installing DreamBooth locally bears some challenges, but it wasn't really complicated. Understanding and tuning the parameters, that was really time consuming. So I had to decide whether I wanted to make another video just showing my parameters, fast forward the training process and show some results, or give you a summary of all the things I've learned during my journey with DreamBooth. Because if you try DreamBooth yourself with my parameters and the results do not meet your expectations, shouldn't you know which parameters to tune in order to improve the results yourself? So the video is longer than expected, but it's worth watching completely. In this video we will use Automatic1111 and its DreamBooth extension. I know the last update of the extension was 3 months ago and the UI is different from the older one, but I'll show you how to use it and which parameters to choose. Regarding GPUs, for NVIDIA users the installation shouldn't be a big deal. For AMD users, I've managed to run Automatic1111 including the DreamBooth extension with Luda on Windows. See this video and the related short regarding the installation of Luda. I haven't found a way to install the extension under Linux and my VRAM 5.6. This was mainly related to the bits and bytes extension, which currently doesn't seem to be compatible with VRAM. As usual, VRAM is an issue. I've included the chapter about optimizing it. Well, here comes the fun part. Let's begin the installation. First, let's install the DreamBooth extension. In the Extensions tab, in Available, we can simply load from. Here is already a URL. And then there is a list of all available extensions. Here we type in DreamBooth and there is one single extension for DreamBooth. You can install it by pressing the Install button. Then in the Installed tab, you press Apply and Restart UI. Well, I won't do this, as you can see it's already installed on my machine. Here is the SD DreamBooth extension. In order to train our model, we go to the DreamBooth tab. The UI of this extension has been changed quite a while ago, but I will show you what has to be considered and which parameters to set in order to successfully create your own models. Press the button Show Advanced, because only then you have access to all parameters, and we will, well, change even some of the parameters which are hidden when not using Advanced. Now I could select simply one of the models I have created so far, but we want to create a new model, so we change to the Create tab within the model settings. I want to train the model with pictures of myself, so I call it Patrick. Then usually I type in the model name. In this case I want to use Absolute Reality as a base model. I haven't used this so far for creating DreamBooth models, so this is special for this tutorial. Absolute Reality, and then some version, well, 01 I think is quite okay. Then we have to select the model type. We have the option to use 1.x. In this case Absolute Reality is a 1.5 model. We could use the 2.x models, but there are no good custom models. We can use SDXL models. This works but consumes lots of VRAM and GPU power. ControlNet, well, I haven't used that so far. The source checkpoint, well, in our case, that's this absolute reality. By the way, what you can see here, these are all trained checkpoints. I will explain later what that means and what these numbers here behind the names. You can automatically save some of these checkpoints at certain stages of your training, but more on this later. By the way, it's a good idea to choose a custom model as a source checkpoint. I have tried training both the base model 1.5 as well as 2.1, and the results have been, well, quite bad. Not comparable with the results we can get, for example, from Epic Realism or DreamBooth, and I'm sure Absolute Reality will be another good candidate to use as a base model for training. Usually I check unfreeze model and I do not check extract EMA bytes. Well, in most cases this is simply not required. So we press create model. Now this takes some seconds. What I will do now is simply selecting one of the models I have trained so far, in this case the DreamShaper model, and load its settings. This is simply in order not to type in everything again, but I will show you every parameters I have changed and the models I suggest to be chosen. So we have loaded the settings from an older training model, and we will use it with the newly created Absolute Reality model. Now, after selecting this Absolute Reality model, I can save the settings, and you see the warning. And in fact, what will be done here is the parameters I have loaded from my older model will be saved into this new model. That's just for the ease of use, in order to show you what I did and not requiring everything to type in again. Nevertheless, be careful about that and make sure to select the right model, especially after you have created a model, when loading settings and saving settings from older models. And well, it's possible even to destroy an older model, or at least the parameters from an older model, if you by accident load settings from a new model with default parameters, save it to an older model. So be careful with that. The two main tabs we have to consider here are concepts and the parameters. We start with concepts first, because here we select some base settings, as you will see in the next minutes. Although it says concept 1, 2, 3 and 4, I have usually only used concept 1. I think it's possible to train several concepts, up to 4 concepts in one go, but well, I just wanna create another model with pictures of myself, so it's not required to choose anything else. If you're using an AMD GPU and experience exactly this error when generating the class images, I have a solution for you. In concept 1 we have 3 different tabs. The first one is instance images, and the first entry is a directory pointing to our training images. So the images we want to use for training our model. In fact, the training images are most important for training our model, because the better our training images, the better the resulting model and the better the output of the model. Well, here you can see a collection of 7 images. 7 is a very low number. It's better to use even more images, but it's important to have a different, well, expression of the face, then different backgrounds. You see, I'm usually wearing different cloth, and all that has to be different, because otherwise, and now I show you what it should not look like. This is an example with well, more training images, 25 images, but as I've experienced, this is a very bad idea, because well, I'm always wearing the same shirt, the background is always same, and after a very few training steps, all generated images of the resulting model looked same. So overtraining and overfitting was very fast. It's a bad idea to use these, well, very similar pictures. It's a good idea to include, say, some upper body shots and concentrate most of the time on, well, portrait close-ups of your face, but well, as I said, don't use always same cloth and same background. This will not work. And what we have seen before, that was these only 7 pictures, but there are very different, and that's much better for training our model. So keep that in mind. And in contrast to me, you can even include more images and maybe even more upper body shots. So say 10 to 15 or 20% upper body shots, rest close-ups of your face, and that should work. In the name you see there is a hint on no captions. You can use captions describing the compositions of your images, and yeah, there was a slight difference when I tried to use captions. So even using captions is not that easy, because you should know what you're doing and how to describe them. I have both used auto-generated captions. That was not successful. Then I manually created some captions. That was a bit better. But the effort spent on creating captions in comparison with the different or maybe improved result, it's not worth the additional work spending on captions. At least that was the result of my tests. In case you are using captions and have made a different experience, please write to the comments. Regarding the prompt, you should use a unique keyword. In my case, that's Patrick, my name, next tech, and AI, so anti-AA. That's for sure unique in this world. You might add photo off, but that's not a must. In fact, when I did it, it looked a bit like when just using the keyword photo in a prompt in the resulting model, then still it had generated pictures of myself, even when I did not add Patrick anti-AA. So, well, both keywords are somehow trained. You could think about omitting the photo off. That's not really important. The instance token, in fact, that's what I was talking about, using a unique keyword. So that's what identifies the trained face. Regarding the class token, you can use person or, well, man in my case. There's not much of a difference I have experienced in my test. Depending on the class token, you want to include some class images. The class images should be related to the class token you're using and to the prompt you're using. So person, man, woman, whatever you have put in the instance images. In the directory there are your class images. I've simply taken these class images from a website. So this guy has provided 1500 images on his GitHub page, and you can simply download the zip file and extract extract the whole thing to one of your directories and then, well, place the name of the directory here. The result is a collection of, as I said, 1500 class images related to person. In fact, they're working good enough for me. You might ask why using class images. In fact, there are two reasons. The very first reason, well, not a good reason for me, is not to override other persons within your model. So if you are training a base model, then it will already include lots of persons, which of course look different than you. And by using the class images, you will make the train process considering that in order not to override the other persons, but usually you will use the trained model anyhow in order to, well, generate most of the time images of the trained face. So at least that was not the most important reason for me. What's much more important is the second reason, and that is in order to avoid overtraining and overfitting. So as I've learned from several tests, it's a good idea to include the class images, because then it's much easier to train without overtraining and overfitting. I have added a negative prompt too. That is used including the CFG and the classification steps in case you want to have the DreamBooth extension generate the class images itself. That is possible, and I have read some people might prefer that. When I've tried that, I have not experienced much improvement over the downloaded class images, but you can try yourself. Just put here an empty directory and the DreamBooth extension will automatically generate the required number of class images for you. If you're using an AMD GPU and experience exactly this error when generating the class images, I have a solution for you. So you can search for the file mentioned in the error description, attention processor PY, and there it is hinted to the set use memory efficient attention XFormers method. What I simply did was well, commenting this line and setting a simple if false, so all code below this if false is not executed anymore, and by doing it that way I was able to generate class images. The more easy solution is not generate class images at all, but simply download them from, well, one of the sources you can find in the net. The number of class images per instance image, or, well, training image, I would suggest using at least 10. The more is better. So with my 7 training images, I've chosen the maximum of 100 class images. And if you have 100 training images, then you can still use 15 class images in case you're using the same 1500 class images I have downloaded. The sample images, well, they are used to create samples during the training process so that you can follow the training process and see the, well, improvements of your generated images. For sample image prompt, we are usually using the instance token and the class token, but as I've experienced, the instance token is usually good enough. No need to add the class token, but by doing it that way, you're on the safe side. You can use well, negative prompt, and that's my negative prompt. So far it works quite okay. Regarding the number of samples, well, I usually choose 2. You could use more of these sample images, but keep in mind generating all those samples takes time, and you could even think about setting it to 0 because this speeds up the training process, although you cannot follow the development of the training anymore. So I would suggest to have at least 1 or 2 samples being generated in order to follow the steps of your training process and the improvement during the whole process. For the sample seed, I usually choose -1 in order to always have different sample images. You could choose some constants here in order to see the development of certain images. Regarding sample CFG and sample steps, we have a look at the web page of the model, and there we can see it's suggested to have a CFG between 4.5 and 10 and steps between 25 and 30. So 30 is okay, and we lower the CFG to somewhere between the 4.5 and 10. I think 7 is a safe choice here. So far for the settings and concepts. Now let's continue with the parameters. When fine-tuning your model, resist the urge to change multiple parameters at once. Instead, adjust one parameter at a time and carefully observe the results. I will hint at the 2 main parameters you might choose when learning about DreamBooth. Don't touch the rest of the parameters. You can try this once you've learned what you're doing. In fact, I suggest starting with my original parameters and checking if the installation works. Then you can start modifying the parameters. Now I'll show you the best parameters for my training set based on the models from Epic Realism and Dreamshaper. In a later chapter we'll have a look at which parameters to tune in order to save some VRAM so that you can use DreamBooth even with GPUs which have, well, not that much VRAM. In the performance section we don't use EMA. That has just a very little influence and consumes lots of VRAM. Optimizer, well, I have tried several, at least for my AMD graphics card. There is Lion the best choice. For NVIDIA GPUs you could try the 8-bit Adam W because it consumes less VRAM, but I think the performance is best with Lion. Feel free to choose other optimizers like Tiger for example, but for example Adder Factor was not as good as Lion, and so we will continue in this video with the Lion optimizer. Mixed precision is FP16. If you have one of the latest GPUs, you could try BF16, but according to what I have read, FP16 is a safe choice and might be even the better choice, so we choose FP16. Then full mixed precision is selected. Memory attention, well, I select the default. Cache latence is checked. Train unit, and this is important. If you're using DreamBooth for the very first time or experiencing any trouble, then set text encoder training to 0 so it is not used. In fact, that was one of the first things I had to learn about this DreamBooth extension when using both unit and the text encoder training. Overtraining and overfitting is very fast and the results are not usable. In the literature it is suggested to have values between 0.4 and 0.7 Even 1 is possible, but when I did some tests with these settings, I always experienced, well, overtraining, overfitting. The results have been definitely not usable at all. So my setting for Dream Shaper and Epic Realism was 0.1, and this works. But if you still experience any trouble overtraining, set it to 0, because I have tried without any text encoder training and the results have been okay. With a little bit of text encoder training, the results have been better, but yeah, just in case you have some trouble, 0 is a safe choice too. We don't touch the offset noise. Clip skip is another thing we should pay attention to. In most cases you can simply set it to 1, that's a safe choice. If you have some hints in the description of your base model setting it to 2, then this is another option, but usually we will put it to 1. Weight decay and tank weight decay, I have never touched that. The tank gradient clip norm, well, that's a different story. As I said some seconds ago, I started with higher values of the text encoder training, experiencing, well, lots of overfitting and overtraining, and in this case the tank gradient clip norm was well, the parameter that saved the training process. So in case you really want to try higher values for the text encoder training, then you should set the tank gradient clip norm to values like 2, for example. So I had best results with 2, 3 or 4 is possible too, but for sure not 0 if you have a higher value of the step ratio of text encoder training. Nevertheless, for the training we're doing right now, we set this training to 0.1, and in this case we don't need to touch the tank gradient clip norm, set it to 0. The next parameters I have not touched and used the default values. Interval section, well, that is quite important. In order not to get confused when tuning the parameters according to your training images and the model, you should concentrate on exactly 2 parameters. Regarding what I have read, usually you should have training steps between 100 and 200 steps per image, but with only 7 images I made the experience that it's quite good to have some more steps, but that's one of the parameters you should, well, tune yourself in order to get best results. More on that later. The next 2 parameters I have not touched. Save model frequency and save previews frequency. That is quite interesting, because during the training process you will have the option to automatically save the model every, well, in this case 50 epochs. And for the previews, well, these are the samples you have defined before. You remember we have chosen to generate 2 sample pictures, and by setting a value here you decide after how many epochs such sample pictures are generated. In fact, I know some people setting these values to 5, so generating very many sample pictures in order to visualize the process and the development of the training, and even saving the model more often. But be aware, the saving process of the model and the creation of the sample pictures, that takes some time, usually even more time than just doing the training steps. So be aware, the higher or the lower the value, the longer the process will take. We set the values back to 50 because for me this 50 combined with the 300 training steps per image, well, that was a good choice, but I think you have to change these values if you take more training images. One thing that was curious for me was well, the number of training steps for the whole process. In fact, for me it looks like every epoch, so step per image, was the double than I have expected. So with my 7 training images, each epoch was not 7 steps but 14 steps, and I simply do not know why. Even when deactivating the UNet or the text encoder training, still I had 2 images per epoch. Even when deactivating the UNet or the text encoder training, still I had 2 training steps for each image in an epoch. This was independent from all parameter settings, and as I said, I do not know why I have 2 steps per image per epoch. If you know an answer, please write to the comments. The batch sizes. You might set batch size to 1, that's for sure a safe choice. I'm using batch size 2, especially with my odd number of training images. I had the impression the training process was more stable, but I cannot prove it. The rest of the parameters I have not touched. Learning rate. Learning rate is the second very important training parameter. As you can see, I've set the learning rate both for the UNet as well as for the text encoder learning rate to, well, that's 0.501, and that's both for the UNet training as well as for the text encoder training. You can try higher values, especially if your training set is larger, say 50 or 100 training images, but most probably you will experience overtraining and overfitting very fast. For the learning rate scheduler, constant with warm-up is a safe choice. I've tried some of these options and always ended with constant with warm-up. For the warm-up steps, I've taken 10% of the whole steps to be expected. So you remember we have 300 steps per image, that's our selection here. Then we have 7 training images, which is 2100. And as I said, for some reason I have the double number of steps, so the result 4200. Here we have 420 warm-up steps, which works quite good. So LoRa I have not touched. Regarding the image processing, the default value is 512. Although you can generate images with Epic Realism and DreamShaper up to, well, 768 by 512 in very good quality, I had not the impression that I have to change something here, so stay with the 512. That's a safe choice, especially with the Stable Diffusion 1.5 custom models. I have not touched the other 2 parameters. Prior loss, that's something we should consider too. The prior loss rate reflects the influence of our class images on the training process. And I think there are values suggested between 0.5 and 0.7. In fact, in my experiments and tests, I had the impression setting it to 1 is the best choice. When I used different values, especially very low values, then I have experienced very fast overtraining and overfitting. So simply set it to 1 and forget this parameter. You need the class images and the influence of the class images for the training process, at least that was my experience. Let's have a look at the saving section. All stays to the default value except for generate the checkpoint file when saving during training. You remember that we have set the value to 50, so all 50 epochs a new checkpoint file is generated. That's not done if you uncheck this parameter, so we check it in order to get these checkpoint files, these extra checkpoint files being saved. In the image generation I haven't touched anything, but I've changed at least one parameter in the extra section. The sanity samples, well, that's in order to see the development of your training process. Similar to the samples, you remember that we have set the parameters to generate 2 samples. Here we have a third sample image being generated, and I have a different prompt, as you can see. The reason is simply I want to see if there is still some, well, reaction to our prompt. So if your sanity sample at some point looks like the person you are training, but without green hair, then you're experiencing overtraining and overfitting. Means the generation process of your images does not use anything from the prompt at all. You could use anything like, well, green hair, blue hair, wearing a hat, holding a camera, although things like wearing a hat and holding a camera are more complex. Green hair is less complex and you will have a better hint. Somehow the generation, well, it does not include at all a camera or a hat, so that's in my opinion a safe choice in order to see the training process and at which point it loses the connection to the prompts and does some overfitting and overtraining. For the sanity sample negative prompt, you could choose the same as you've used for the samples. I think we should just copy it from the sample images, put it into the parameters. Here we are. The sanity sample seed, well, that's simply a constant. You can freely choose. The default for 20 is a safe choice. I haven't touched any of the following parameters, and so yeah, that's all for the parameters section, and we are good to go. Oh, before we start the training, let's have a look at the parameters you can tune in order to reduce the VRAM consumption. Don't use EMA. That's what I've already mentioned. And as an optimizer, if you have an NVIDIA graphics card, choose the 8-bit AMD, but it's very probable that you have to change the training or the learning rate too, so be aware of that. Otherwise, well, stick to Lion. Cache latence, that has an enormous influence on the VRAM. Deactivate in order to save lots of VRAM. You can even think about setting the text encoder training to 0, because then the text encoder is not used and this will save some more VRAM. Well, it has an influence on the training process, so it should be your last resort setting this parameter. Then what still has an influence on the VRAM is the batch size. I'm using 2 as I've explained before, but if you don't have enough VRAM, set it to 1. The rest of the parameters should not have such a big influence on the VRAM consumption. I have an AMD R6800 with 16 GB VRAM. As I have experienced in the model trainings before, it consumes with these settings up to 12 GB VRAM. With the optimization you have seen a moment before, you should be able to reduce the required amount of VRAM to something below 10 GB. So now we are ready for the training process. Depending on your dataset and desired quality, training can take anywhere from 30 minutes to several hours, so be patient. And if you want to see more tutorials like this, press the subscribe button. We fast forward the training process. So the training was successfully finished, and before we have a look at the results, let me give you 2 hints regarding the training process. The first hint is regarding the training itself. In fact, the result is always different. So if you start the training twice or 3 or 4 times, you will always get different results of different quality. So if you're not satisfied with one of your trainings, go back to the Model tab and create, say, another version. In this case, we would create a version 02, for example. And after creating the model, you could simply make sure to select it here in the model selection section and then save the settings, and it would use exactly the parameters and settings from the training before. Nevertheless, make sure not to use save settings over an older model, because the parameters of this older model would be overwritten. Well, and after you have created another version of the model, save the settings, you could press train again and do another training process with the newly created model. And you can do this until you're satisfied with one of the trainings. The second hint is related to the number of training steps and saving the model. As you remember, we have selected 30 steps per image and saved the model every 50 epochs. Some people prefer not saving the model at all during the training, only at the end of a training process, and select a very small number of training steps per image, say only 10 or 20. And what they do then is they train the model for these very few training steps. Then they use the model on the text to image tab, test if they are satisfied with the output, and if they are not satisfied and the model is not trained enough, then they go back to DreamBooth and press the train button again. And after pressing the train button, well, then the whole train process starts again, but it continues with the training you have done so far. Then again, you can have a look at the output, test the results of the model, and if you're not satisfied, press train again, and so on. And you can simply repeat that until the model has the sufficient quality. Let's have a look at the generated sample files. In your Stable Diffusion directory, you find models, DreamBooth, and here's a directory for the newly created model, Absolute Reality, and there inside we have the samples. We do not use captions, you can simply ignore the txt files. We open the samples. Yeah, somehow it's me, but quite abstract and an unexpected style. Let's have a short look at the generated images. You see there is green hair, so the generation follows the prompt. This looks a bit like me, that not really. And yeah, we have the green hair, so everything is okay. That's training step 2100, so half of the steps. That's, well, somehow similar, but it's not me. And yeah, still green hair, everything okay. This is a bit like me. That not, but with green hair. Yes. Well, the one before. That looks a bit like me. This not really, and this is well, maybe a brother, don't know, but the hair is green, so it's still okay. Nevertheless, if we have a look at these special samples with the green hair, then you can see the green color, well, it's less intensive. So the generation is okay till 2800, and after that, well, it's still following the prompt, but here we have to be careful. Now let's test the generated checkpoints. We go to the text to image tab and enter a suitable prompt. So what's the purpose of this prompt? First of all, we want to see whether the generated person matches our source images, and we want to check if the generation still follows the prompt. So wearing a red sweatshirt, that's just to check whether, well, the most easy exercise for such a model is to change the color. Holding a football is even more difficult. Well, even when not training a model, that might be difficult, and not every generated image will have such a football in place. But if we are seeing the football, then we can be quite sure that the model still follows the prompt. Well, and that is just to generate a better image. Okay, and you see we have 6 additional checkpoints, and I think regarding the training result we should concentrate on those from 2800 to 4200. That can easily be achieved by selecting the script XYZ plot. Now the special trick is to choose for X not the seed but the checkpoint name. And now we can simply add the absolute reality checkpoints, in this case 2800, 3500 for 2, so these 3, and I suggest for the Y type, let's select the CFG. The suggestion was from 4.5 to 10, so we follow this suggestion, for example, by typing 4, 6, 8, 10. For the Z type, we could additionally choose the sampling steps, but I think with the range of 25 to 30, that's not required, and according to my experience, the steps do not have such a big influence like the CFG scale. Now, before generating the whole images, we select include sub-images and include subgrids. Yeah, that's all. So let's start the generation. My impression is the lower the CFG value, the closer the generated images are to the source images, and the higher the CFG scale, well, the more it follows the prompt, although the value 10 is not the best option. We want to generate 20 random images, so with seed -1, and the farmost right checkpoint, that's the 4200 checkpoint. Well, if you're using Stable Diffusion for quite a while, then you know that you have to generate usually some dozens of images in order to get at least a good one, and with a trained model that's not different, so it's time for the final step. We have a look at the Absolute Reality webpage, see if there is a suitable image. Oh, that is not too bad. Then we copy the generation data, switch off high-res fix in order to have a faster generation. What's the result of the generation? Okay, that's a bit like me, but maybe not completely, and the reason is simply we have not chosen the keyword, but as I've said in the very beginning, here we have the word photo, and I think it reacts very similar to using the keyword. So let's try again. Well, somehow that's indeed me, maybe a bit slimmer, and the final approach would be to generate several of these images, take the best one, and then we are good to go. Well, and now it's up to you to decide whether some of these images look like me. Sometimes even with careful parameter tuning you might get inconsistent results. This is part of the nature of AI models and requires patience and experimentation. Nevertheless, if you find this video useful, please leave a like.